Today, we are going on a little trip through our solar system, and we're going to try to understand the single most important thing that makes life on Earth possible. And that's our atmosphere, that really thin blue line you see from space, separating us from, well, from everything else.
I mean, have you ever really stopped to think about it? Why is our world this lush, wet, living paradise, while our next door neighbors, Venus and Mars, are a blistering hellscape and a frozen wasteland? The answer, as it turns out, is all about the air. Okay, let's get on the same page. What even is an atmosphere? It's basically just a layer of gas wrapped around a planet. Here on Earth, it's mostly nitrogen and oxygen. And, it's incredibly thin. Most of it is packed into just the first 10 kilometers above our heads.
Now, the absolute best way to think about how an atmosphere works is to picture it as a blanket. Simple, right? It can be a super thick and heavy blanket, a really thin and useless one, or it can be just right. And that one difference is everything. It's the difference between a paradise and total oblivion.
So let's start right here at home. How exactly does our planet's vital blanket keep us all alive? Well, the answer is a process you've definitely heard of, but understanding how it really works is, well, it's the whole key. It's called the greenhouse effect. So here's the deal. First, sunlight, the visible light, zips right through our atmosphere and warms up the ground. Easy enough. Then the warm ground radiates that heat back out, but, and this is crucial, it's not sunlight anymore. It's infrared heat. And that is where our blanket gets to work. Certain gases in the atmosphere, like carbon dioxide, are amazing at grabbing that outgoing heat and holding on to it. Now, I know what you might be thinking, greenhouse effect isn't that bad? But no, not at all. It's absolutely essential. It's a critical planetary function. Without this atmospheric blanket trapping a bit of that heat, Earth would be a frozen snowball. The greenhouse effect is what makes our world livable. And to really, truly appreciate our just right blanket, we need to pay a visit to the neighbors. So let's take a quick look at two other worlds, just to see what happens when that blanket isn't quite right. This is really the heart of the matter. This is the question that decides the fate of Venus and Mars. What happens when a planet gets way too much of a good thing, or not nearly enough? Okay, look at this. These numbers tell an incredible story. That no greenhouse column, that's what scientists figured the temperature should be based only on how far a planet is from the sun. Now look at the actual temperature. For Earth, there's a nice little bump. For Mars, barely anything. But look at Venus. The difference is just staggering. And this right here just blows my mind. Because Venus has these super bright reflective clouds, it actually absorbs less sunlight than we do here on Earth. So get this, without its atmosphere, Venus would actually be of frozen rock, even though it's way closer to the sun. The whole tragic story of Venus is right here, in this one number. Its atmosphere adds an unbelievable 510 degrees Celsius of warming. That is the greenhouse effect gone completely off the rails. Venus is the ultimate cautionary tale. Its atmosphere is basically a thick, crushing blanket of pure carbon dioxide. It trapped so much heat that it literally boiled the planet's oceans away and baked the surface into a wasteland hot enough to melt lead.
Now, compare that to Earth. Our greenhouse effect, our nice cozy blanket, adds a much more gentle 31 degrees Celsius of warmth.
And that 31 degrees, that's our magic number. That is the just right warmth, the Goldilocks zone. It's what took our planet's average temperature from well below freezing up to a comfortable 15 degrees. It's the heat that allows for vast, liquid oceans, which, is where life got started. Okay, so now let's hop over to our other neighbor, Mars. If Venus's blanket is way too thick, Mars's is like a thin, threadbare sheet. Billions of years ago, Mars basically had its atmosphere stripped away and lost to space, leaving it cold, unprotected, and unable to hold on to any heat. So while Venus is an oven, Mars is a deep freezer. It's the ghost of a world, a planet that might have had water once, but it's now locked away as ice because its pathetically thin atmosphere just can't trap enough of the sun's heat to keep the planet warm. And all of this brings us back home to maybe the biggest mystery of all. Venus spiraled into a furnace. Mars froze solid. So how on earth did our planet manage to stay so stable for so incredibly long? Well, the answer isn't just that we got lucky.
It turns out our planet has a secret weapon, an incredible self-regulating system that has acted like a global thermostat for eons.
It's called the carbon dioxide cycle, and it is honestly amazing. So here's how it works. CO2 in the air dissolves into rainwater. That rain then hits rocks on land and erodes them, washing carbon down into the oceans. In the ocean, tiny creatures use that carbon to make their shells, and when they die, they sink and eventually become a rock, locking the carbon away on the seafloor. But that's not the end. Tectonic plates eventually drag those rocks down deep into the Earth's mantle, where they melt, and eventually volcanoes spew that trapped CO2 right back out into the atmosphere.
You see what's happening? It's a self-correcting loop. If the planet gets too hot, more water evaporates, which means more rain, which pulls more CO2 out of the air, and that cools things down. If the planet gets too cold, volcanoes just keep chugging along, pumping out CO2 that builds up in the atmosphere, warming things back up. It's a brilliant planetary thermostat.
For billions of years, this natural thermostat has kept Earth in a beautiful, stable balance. But in just the last tiny fraction of a cosmic second, a new force has started messing with the dial. Take a look at this. For hundreds of thousands of years, CO2 levels naturally bounced up and down, sure, but they stayed inside a pretty predictable range. Now, look all the way to the right of the chart. That vertical spike, that's us. The amount of CO2 in the air today is higher than it's been in at least 500,000 years, and almost all of that jump happened in just the last 50. We're basically overriding that slow, natural cycle. By digging up and burning fossil fuels, we are taking carbon that was locked away for hundreds of millions of years and just pumping it straight into the atmosphere. Far, far faster than the planet's natural thermostat can possibly handle.
And that brings us to the final thought. We've seen the story of a planet with a blanket that's way too thick and one that's way too thin. We just happen to live on the one that was, for eons, just right. The real question now is, what story are we choosing to write for our own thin blue line?